going? Alright. So when you have these expressions, it could be just about anything depending on what your number is, but there are certain numbers that this variable cannot be. Right? It cannot be something that is going to make the entire expression undefined. Okay? So what would make this expression undefined? Well, when do we get undefined numbers?
Denominator equals 0.
Yeah, so I don't even care about this. Really, if I'm trying to find what the value for h can be, all I'm doing is focusing on the denominator and saying, let's make an equation where we say 4 times h, the denominator, is equal to 0. And solve for that. When I do that, I divide both sides by 4. H ends up being 0. And really what that means is h can be any number. It could be 1, it could be 1,000, it could be 17.6, right? Any number you want, and it's going to make this expression worth different things. The only thing it cannot be is 0. Because if I try to say h is 0, now I get 9 divided by 0, and that's undefined. And that's what we call an excluded value, right? Same thing's happening here. What is p plus 2 divided by p plus 4? Well, it could be anything in the world, right? This expression could be something very small, because maybe p is just equal to 1. Or it could be some larger number. It depends what we put as a value for p. But there's some things that it cannot be. And so again, I'm going to focus on the denominator and say, it can be anything I want it to be, but p plus 4 can't equal 0. This one you can probably do in your head. What's the only thing that I can't have there?
Negative 4.
That what?
Negative.
Negative 4. Okay, because negative 4 plus 4 is going to make this whole thing down here 0. Okay, so if I wanted to, I could pull that out and say, well, p plus 4 equals 0. That's really what you're doing to solve for that. Subtract 4 from both sides. So p cannot equal negative 4. Okay? Can you do the last one on your own? Go ahead. Solve for the excluded value. What can g not be? No. 5. 3g minus 15 equals 0 is how you would do that. And then you find out, well, if I plugged in 5, 15 minus 15 is 0, and that would give me an undefined number. Could I use 4? Could g possibly equal 4? Yeah. Could g equal 17? Yeah. Could g equal 0? Yeah. Sure, it could be any of those numbers. The only thing it cannot be is 5, because 5 would make that whole term, the whole expression undefined. Okay? So now we're going to kind of combine two things. First of all, we're going to say, let's simplify this, and then once we simplify and we get down to something that maybe looks like this or this or this, then we have to decide which numbers are excluded. Which numbers could the variable not be? All right? So first of all, 4a times 3 divided by 2a times, or a to the third and a to the second. How can I simplify that? Well, if I wanted to write this out, isn't the numerator 4 times a times a times a? Isn't that what 4 times a to the third is? Denominator is 2 times a times a. Yeah.
You could have 2a on the top and 1 on the bottom.
Okay. Where are you getting 2a from?
Because 2a's from the top and 2a's from the bottom cancel out.
Yeah, that and that cancel, and then
make that 2 over 1.
yeah, divide that by 2 and divide that by 2. Okay, so when I simplify this whole thing, really it's 2 times a on the top divided by 1, which is nothing. So when I simplify this expression, it's 2a. When I look at 2a, is there anything that a can't be? In other words, are there any excluded values?
0.
So you're saying a can't be 0?
Wait. No, there aren't, because that's the numerator.
Yeah. Because a could still be 0. If a is 0, then the whole expression is worth 0. Could a be negative 1? Sure. Then it would be a value of negative 2. Could a be 100? Sure, it would be a value of 200. Okay, so a can be absolutely anything at this point, and there are no excluded values. which seems kinda strange, cause you look back here and go, well, wait a second. I've got a denominator there. Let's see what happens if I would've set this equal to 0. I say 2a squared equals 0. I divide both sides by 2. And say, well, a squared equals 0. What times itself equals 0? 0 times 0 equals 0? I guess, but because we have to simplify this, we could still plug in anything, because they're gonna cancel. Does that make sense? Okay, do the same thing down here. First of all, I'll go ahead and simplify. You guys can do that one on your own. I would suggest factoring first, by the way. For example, the bottom could look something like 5 times z minus 2. Did it look like this when you factored? I noticed that from both of these terms, I can pull out a 3 and a z. I noticed that both of these terms, I can pull out a 5. Why does that end up being helpful? Noah? What's in parentheses in both of them?
Oh, z minus 2.
So z minus 2 and z minus 2 can just cancel out. Right? Same on the top and the bottom. So really, when I simplify that whole expression, I'm just left with 3z over 5. And again, my question is there anything that you can't plug in? Are there any restricted numbers that doesn't work? Yeah. 0? I can plug 0 in. If I plug 0 in for z, it's 3 times 0 over 5, which is 0. That's okay. 0 is a valid number.
It's in the numerator, it can be any.
Correct. Yeah. So there are no excluded values in this one. And again, let's just test this out, because what we were doing before to find excluded values was we took the denominator and said, well, 5z minus 10 cannot equal 0. So what would make it 0? Add 10 to both sides, you get 5z equals 10. Divide by 5, you'd have z equals 2. And we would have just said, well, you can't plug 2 in here, can you? Is that true? Can we plug 2 in there or not? We should still be able to, right? Because if we plug 2, remember this all simplifies, we would still get 6 over 5 as a value. Make sense? Okay, we'll come back to that in just a second. Simplify these two and then find excluded values. You guys can do that one on your own.